It's not uncommon for apprentices in the electrical field to experience feelings of isolation and a lack of support. Sometimes, journeymen might be dealing with their own pressures and may not be readily available to provide guidance. When an environment doesn't foster mentorship and a culture of continuous learning, it can be tough for an apprentice to develop properly. If faced with this situation, firstly try communicating with the foreman. Express your concerns, emphasizing your need for support. Explain that you have a strong desire to learn and improve and that guidance is essential for you to progress effectively. Secondly, seek mentorship outside of your current company. Try to find a licensed electrician who's willing to mentor you and answer your questions. You might consider reaching out to local electrical organizations or electrical trade schools. Thirdly, attend industry events. Trade shows, conferences, and workshops are great opportunities to connect with other professionals and learn from experts in the field. Fourthly, never hesitate to ask questions. Keep in mind that even experienced electricians seek clarification or assistance when they need it. It's far better to ask questions and receive guidance than to make mistakes that could have serious consequences. Fifthly, explore opportunities with other companies. If your current work environment doesn't promote your growth, consider researching and applying to companies that prioritize apprentice training and support. Some companies in Massachusetts known for strong apprentice programs include Linear Electric, Cushing Electrical, Sutco, NECA Chapter 103, and Ivy Local 223. Here are some additional tips to keep in mind. 1. Stay curious. Engage with the National Electrical Code, industry publications, and online forums to expand your knowledge base. 2. Be proactive. Take the initiative to learn new skills and accept new responsibilities. Offer to assist journeymen with tasks even if they seem outside your comfort zone. 3. Build relationships. Network with other apprentices, electricians, and industry professionals. They can offer valuable support and share insights that can help you on your journey. Remember your goals. Keep in mind that becoming a licensed electrician requires sustained effort, support, and perseverance. Maintain your motivation and don't let setbacks discourage you. Electrical work can be challenging, and understanding the NEC is crucial. For example, Article 250 covers grounding and bonding requirements which are vital for safety. When working on a 2000 amp service, proper grounding ensures that fault currents have a safe path to return to the source, minimizing the risk of electrical shock and fire hazards. Grounding electrode conductors must be sized according to NEC Table 250.66 based on the size of the service entrance conductors. Bonding jumpers are used to connect metallic parts together, creating an electrically continuous path. These jumpers must be sized according to NEC Table 250.102. For a 2000 amp service, these sizes will be substantial, often requiring multiple conductors or large copper bars. The physical installation requires careful attention to detail. Grounding and bonding connections must be mechanically sound and electrically conductive. Use appropriate connectors listed for grounding and bonding purposes. Ensure that all surfaces are clean and free from corrosion before making connections. Torque connections to the manufacturer's specifications to ensure a reliable connection. Remember that improper grounding and bonding can have serious consequences. It can lead to equipment damage, electrical shocks, and even fires. Always double-check your work and consult with a qualified electrician if you have any questions. Another critical aspect of electrical work is understanding overcurrent protection. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. When working with a 2000 amp service, the main overcurrent protection device must be carefully selected to coordinate with the service conductors and the downstream loads. NEC Section 240.4 provides the general requirements for overcurrent protection. The size of the overcurrent protection device must not exceed the ampacity of the conductors it protects, unless specific exceptions apply. Coordination studies are often performed to ensure that overcurrent devices operate selectively. This means that the overcurrent device closest to the fault should trip first, minimizing the impact on the rest of the electrical system. For example, If a fault occurs on a branch circuit, only the branch circuit breaker should trip, not the main breaker. Understanding voltage drop is also essential, especially in large electrical systems. Voltage drop occurs when electrical current flows through a conductor, causing a reduction in voltage at the load end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Chapter 9, Table 8 provides voltage drop calculations. Factors that affect voltage drop include the conductor size, length, and current. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Another important aspect of electrical work is understanding motor control circuits. Motors are used in a wide variety of applications, from pumps and fans to compressors and conveyors. Motor control circuits are used to start, stop, and control the speed of motors. NEC Article 430 provides the requirements for motor circuits. Motor circuits must be protected against overloads, short circuits, and ground faults. Overload protection is typically provided by thermal overload relays, which are designed to trip when the motor draws excessive current for an extended period. Short circuit and ground fault protection is provided by fuses or circuit breakers. Control circuits often use contactors, which are electrically operated switches that can handle large current. Contactors are used to switch the motor on and off, and they can also be used to provide reversing or speed control functions. Understanding the NEC requirements for hazardous locations is also crucial. Hazardous locations are areas where flammable gases, vapors, or dust may be present. These locations require special electrical equipment and wiring methods to prevent explosions and fires. NEC Article 500 classifies hazardous locations based on the type and concentration of the hazardous material. Each classification has specific requirements for electrical equipment, including explosion-proof enclosures, intrinsically safe circuits, and purged and pressurized systems. Working in hazardous locations requires specialized training and certification. It is essential to follow all safety precautions and use only approved equipment. Another critical aspect of electrical work is understanding the principles of power distribution. Power distribution systems are used to deliver electrical power from the utility source to the various loads in a building or facility. These systems typically consist of switchgear, transformers, panel boards, and feeders. Switchgear is used to switch and protect incoming power from the utility. Transformers are used to step down the voltage to levels suitable for use by equipment and appliances. Panel boards are used to distribute power to individual circuits. Feeders are the conductors that carry power from the switchgear to the panel boards. Understanding the principles of power distribution is essential for designing and maintaining safe and reliable electrical systems. It is also important to understand the NEC requirements for renewable energy systems such as solar, photovoltaic, and wind power systems. These systems are becoming increasingly popular as a way to generate clean and sustainable energy. NEC Article 690 provides the requirements for solar photovoltaic systems. These systems must be properly grounded, protected against overcurrents, and disconnected in a safe manner. Wind power systems must also meet specific requirements to ensure safe and reliable operation. Staying up to date with the latest NEC requirements is crucial for all electricians. The NEC is updated every 3 years, and it is important to understand the changes and how they affect your work. Many resources are available to help you stay informed, including online training courses, industry publications, and local code classes. Engaging with these resources can help you enhance your knowledge and ensure that you are working safely and in compliance with the latest regulations. Remember, becoming a skilled electrician requires continuous learning and dedication. Seek out mentorship, stay curious, and never hesitate to ask questions. Your commitment to professional development will lead to a successful and rewarding career in the electrical field. When dealing with a 2000 amp service, remember that the service entrance conductors must be sized according to NEC 310.16 and related tables, taking into account ampacity and dating factors for ambient temperature and the number of conductors in a raceway or cable. For example, If using copper THHN conductors in a raceway with an ambient temperature of 30 degrees Celsius and no more than 3 current carrying conductors, you could reference NEC Table 310.16 for the allowable ampacity based on the conductor size. The sum of the connected loads in the service must not exceed the calculated ampacity of the service entrance conductors, ensuring a safe and reliable installation. The main bonding dumper, which connects the service equipment grounding conductor to the grounded conductor, must be sized according to NEC 250.28. This jumper provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices and minimizing the risk of electrical shock. Additionally, the grounding electrode system for 2000 amp service typically includes a combination of grounding electrodes such as ground rods, ground rings, and metal underground water pipes. These electrodes must be bonded together to form a comprehensive grounding system that provides a low impedance path to earth for fault current. When installing grounding electrodes, adhere to the requirements in NEC 250.52 and 250.53 for proper depth and spacing. For instance, ground rods must be driven at least 8 feet into the earth and spaced at least 6 feet apart. The connections to grounding electrodes must be made with listed connectors and installed in a manner that ensures a permanent and reliable connection. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. These conductors provide a path for fault current to return to the source, protecting personnel from electrical shock. The size of equipment grounding conductors must be determined according to NEC 250.122, based on the size of the overcurrent protective device protecting the circuit. For example, if a circuit is protected by a 20 amp breaker, the minimum size equipment grounding conductor would be 12 American wire gauge copper. All electrical connections must be made with listed connectors and torqued to the manufacturer's specification. Loose or corroded connections can cause excessive heat and voltage drop, leading to equipment malfunction and potential fire hazards. Use an antioxidant compound on aluminum conductors to prevent corrosion. The NEC also requires that all electrical work be performed in a neat and workmanlike manner. This means that conductors must be properly supported and protected, and equipment must be installed in accordance with the manufacturer's instructions. Avoid creating unnecessary bends or kinks in conductors, and ensure that all enclosures are properly sealed to prevent the entry of moisture and dust. Remember, electrical safety is paramount. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as gloves, safety glasses, and arc flash suits. Never take shortcuts or compromise on safety. Your life and the lives of others depend on it. It is also vital to understand the importance of arc flash studies for large electrical services. An arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Arc flash studies are performed to determine the potential arc flash hazard levels and to recommend appropriate personal protective equipment (PPE) for electricians working on the equipment. The results of an arc flash study are typically documented on arc flash labels, which are affixed to the electrical equipment. These labels provide information about the arc flash boundary, the incident energy, and the required PPE. When working on electrical equipment, always refer to the arc flash label and wear the appropriate PPE. For example, if the label indicates a high incident energy, you may need to wear a full arc flash suit, including a hood, gloves, and hearing protection. Proper coordination of overcurrent protective devices is essential for minimizing the impact of arc flash events. Selective coordination ensures that the overcurrent device closest to the fault trips first, limiting the amount of energy released during the arc flash. Coordination studies are typically performed by qualified electrical engineers and involve analyzing the time current characteristics of the overcurrent protective devices. Another important consideration for large electrical services is power quality. Power quality refers to the characteristics of the electrical power supply, including voltage, frequency, and waveform. Poor power quality can cause equipment malfunction, premature failure, and increased energy costs. Common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Once the problems are identified, various mitigation techniques can be used to improve power quality, such as installing surge suppressors, harmonic filters, and voltage regulators. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical equipment. Maintenance activities include inspecting and testing equipment, tightening connections, cleaning components, and replacing worn parts. Develop a comprehensive maintenance plan that includes routine inspections and testing of all critical electrical equipment. Keep detailed records of all maintenance activities, including the date, time, and findings. Use this information to track equipment performance and identify potential problems before they lead to failures. When working with large electrical services, it is also important to understand the principles of load management. Load management involves controlling the timing and amount of electrical power consumed by various loads in a building or facility. The goal of load management is to reduce peak demand, lower energy costs, and improve system reliability. Various load management techniques can be used, such as scheduling loads, shedding loads, and shifting loads. For example, large electrical loads such as air conditioning systems and water heaters can be scheduled to operate during off-peak hours. Non-essential loads can be shed during periods of high demand, and loads can be shifted from one time period to another to reduce peak demand. By implementing effective load management strategies, you can optimize the performance of your electrical system and reduce your energy costs. Consider additional training and certifications to enhance your knowledge and skills. There are many specialized certifications available for electricians, such as Certified Energy Manager, Certified Electrical Safety Compliance Professional, and Certified Photovoltaic Installer. These certifications can demonstrate your expertise and enhance your career prospects. Look for continuing education opportunities that focus on emerging technologies such as smart grids, electric vehicles, and energy storage systems. Staying up to date with the latest advancements in the electrical field will keep you competitive and position you for future success. It's also a good idea to familiarize yourself with relevant industry standards and best practices. Organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and the American National Standards Institute develop standards and guidelines for electrical equipment and installations. Adhering to these standards and best practices can help you ensure the safety, reliability, and efficiency of your electrical work. Remember, becoming a proficient electrician requires a combination of technical knowledge, practical skills, and a commitment to safety. By continuously learning, seeking mentorship, and staying engaged with the industry, you can build a successful and rewarding career. When working on any electrical system, especially a large service like a 2000 amp system, meticulous planning and attention to detail are essential. Before commencing any work, thoroughly review the plans and specifications to ensure a complete understanding of the project requirements. Conduct a detailed site survey to identify any potential hazards or challenges. Develop a comprehensive work plan that outlines the sequence of tasks, the resources required, and the safety precautions to be taken. Obtain all necessary permits and approvals before starting work. Coordinate with other trades to avoid conflicts and ensure a smooth workflow. Throughout the project, maintain clear and open communication with all stakeholders, including the client, the engineer, and other tradespeople. Document all work performed, including measurements, test results, and any deviations from the plans and specifications. This documentation will be invaluable for future maintenance and troubleshooting. After completing the work, conduct a thorough inspection and testing to verify that the system is functioning properly and meets all applicable codes and standards. Provide the client with complete and accurate documentation, including as-built drawings, test reports, and maintenance manuals. Always remember that electrical work is a critical trade that demands the highest level of skill, knowledge, and integrity. By adhering to these principles, you can ensure the safety, reliability, and efficiency of your electrical work and contribute to the well-being of your community.